All right, so today we're going to be talking about Chapter 4, Lesson 5. We're only going to talk about the first part of it, but it's called Computations with Scientific Notation, and we're going to focus on multiplication and division. So if you recall from Lesson 1, I think, or 2, or 3. 3 sounds right. We have to use some properties in order to help us with multiplication and division. Because scientific notation, A, in this case, would always be 10, and then M and N are some other integer. But if you recall, when I have the same bases being multiplied, what I do is I add the exponents. So for example, if I had 10 to the third times 10 to the eighth, this would be 10 to the 3 plus 8, which ultimately would be 10 to the 11th. Same thing. When I'm dividing two bases, what I do is I subtract the exponents. So again, if I have 10 to the third divided by 10 to the eighth, this would get me 10 to the 3 minus 8, which just happens to be 10 to the negative fifth. And in scientific notation, it's absolutely okay to have negative exponents. So let's utilize that information to help us with multiplication and division of scientific notation. So example 1, a dime is 1.35 times 10 to the negative third meters thick. What would be the height if I had a stack of 1 million dimes? Key thing here is scientific notation. So step 1. I want to convert 1 million to scientific notation. So my decimal point is at the very end. I'm going to move it 1, 2, 3, 4, 5, 6 places. So I'm at 1 times 10 to the 6th. Step 2, I'm actually going to take 1.35 times 10 to the negative third and multiply it by 1 times 10 to the 6th. Now, the process that I'm going to use in order to do this, I'm going to use something called the commutative property of multiplication. And because everything is being multiplied together, the commutative property says it doesn't matter the order that things get multiplied in. So I'm going to take this 1.35 and 1, and I'm going to move them by each other. So I now have 1.35 times 1. And then I'm going to take the 2 powers of 10 and move them by each other. So I have 10 to the negative third times 10 to the 6th. I'm going to multiply each one now, so 1.35 times 1 is 1.35. 10 to the negative third times 10 to the 6th. Remember, I'm multiplying here now, so I add the exponents. Negative 3 plus 6 is 3. And now I need to include the units. So a million dimes would be 1.35 times 10 to the third meters tall. This part here is key. You need to move the numbers out front together and the powers of 10 together. It's kind of like those are similar things. We can't combine two things that aren't alike, but we can combine two things that are alike. The 1.35 and the 1 are in the same position, so we can combine those two. And because we're multiplying everything, I multiply those two numbers. Same thing with the powers of 10. They're both powers of 10, so they can be combined. And I'm going to multiply those two because, again, everything is being multiplied together. And I'm going to use my product of powers property, which is this one right here. Two bases multiplied together, I add the exponents. And then I combine those two next to each other again. So let's look at example 2. Very, very similar. It says express 8.32 times 10 to the 7th divided by 1.3 times 10 to the 5th and express in scientific notation. Now, what I really like to do is I like to take like a little squiggly line here and separate right on that multiplication sign the powers of 10 from the factors out front. I'm going to treat this as two separate problems. I'm going to treat this as 8.32 divided by 1.3 times 10 to the 7th divided by 10 to the 5th. And the reason why I can do that is because when I start dividing numbers, those two numbers are the same. They're right on top of each other. I can separate them. And right here with this multiplication sign, because both numbers are being multiplied in the same position, I can separate the fraction and say that the multiplication sign applies to both of them. So I can do this here. So if I do the first one, 8.32 divided by 1.3, that is 6.4 times 10 to the 7th divided by 10 to the 5th. I'm now dividing my powers, so I'm going to subtract the exponents. 7 minus 5 is 2. So that'd be 6.4 times 10 to the 2nd. And last example, example 3, it says the largest planet in our solar system is Jupiter. Has a diameter of about 143,000 kilometers. The smallest planet is Mercury, with a diameter of about 5 times 10 to the 3rd kilometers. So about how many times greater is Jupiter than Mercury? First of all, this question here talks about division. It sounds like it should be multiplication because it says how many times greater. But we're going to be looking at what number we multiply Mercury by to get to Jupiter. So that's going to be a division problem. So first step, I want to convert 143,000 to scientific notation. So here's my decimal point. I'm going to move it 1, 2, 3, 4, 5 places. So this is 1.43 times 10 to the 5th. Step 2, I'm now going to take Jupiter's diameter divided by Mercury's diameter. And again, I'm going to separate the problem out to 1.43 times 5, or divided by 5, times 10 to the 5th divided by 10 to the 3rd. And here's where it gets a little tricky, because 1.43 divided by 5 is 0.286. Over here, division of powers, so I subtract the exponent, so this is times 10 to the 2nd. And here's where it gets confusing. This number is not written correctly in scientific notation. Now, what you can do is convert this to standard form and then back to scientific notation. So what I would do is this number here, the exponent, tells me how many places I move it. So I move it 2 places. It's positive to the right. So this number right here is really 28.6. And I'm going to actually leave it like that, because this number makes a lot of sense. It's about 29 times larger. Now, if I wanted to convert this back to scientific notation, I would have to move the decimal point until I get to a number that's between 1 and less than 10. So a 1-digit number. So this would be 2.86, and I moved it 1 place. But this is so much nicer because 29 is something we understand. this number here, we understand scientific notation, but 29 just makes so much more sense to us. All right, and that is the end of this video. We're going to continue Lesson 5 tomorrow with addition and subtraction of scientific notation, and that's a little bit more tricky. All right, if you have any questions, please let me know.